Hello, Shakhina.
Hello,
How are you?
I'm good. How are you?
You're also good. You must be very, I don't know, happy to be in Tashkent with your
Yeah,
relatives and Uzbek families, Uzbek culture.
yeah.
Did you
It's
go to
very hot here
Samarkand,
though.
also Bukhara?
Oh, we recently came from Samarkand, but not Bihar.
It's so hot, right?
Yeah, Tashkent is hotter than Samarkand though.
Yeah. Okay. Shahina, let's actually recap what we have done so far with you. We started with functions, right? And after that, with some problems about how to find it is domain and range. And after that, we talk about finding the intervals where the function increases, where the function decreases, and also what else? How to combine two functions, right? Composition of two functions, and what else? How to find the global maximum, global minimum, local maximum, local minimum. Do you remember these things?
Yes.
Okay. So now let's practice about how to find the inverse of the function. Actually, this was your homework, actually the self-studying, because if you do every question, it's good, but it takes a lot of time, okay? So let's do some question from here, and after that, we'll continue about finding the inverse of a function. Okay, we'll talk about inverse functions. Okay, so here I think it's a little bit challenging question. Here it says find two functions f and g such that f of g of x is equal to h of x, where h of x is equal to 2 times 3x minus 1 cubed, and here h of x is equal to this. Very similar questions, but just warm up, okay? Then you'll continue with inverse functions. So actually, we are given two functions, right? We know that in a lot of different ways we can combine two functions, right? Each of the functions given here. So what actually can you tell me about function g and the function f?
Um, they both equal h of x.
Maybe g of x, if you see here, right? In different ways I can combine this, but if g of x is equal to 3x minus 1,
Oh
right?
yeah,
At the time, f of x would be what?
2x to the power of 3.
2x cubed, right?
Yes.
Because here f of x, if f of gx, right? If I just write here f of g of x, so which means that that is f of g of x. And what is f of x? It is 2 times g of x cubed because our input value is g of x. And here we have cube. What is g of x? It is 3x minus 1. And how about for 8? H of x is equal to negative 3 over x plus 5 plus 7, right? So how would you define this g of x?
Um, 3 negative or 3 over x plus 5.
Yeah, we can do like this, or we can do 1 over x plus 5. Actually, it's not the only way, right? There are different ways to combine this. But if I take this g of x as 3 over x plus 5, at the time, this f of x would be
Negative x plus 7.
negative x plus 7. Good. Just wait here. Shahina, now let's talk about inverse relations. Do you remember what is a relation? How did they define relation?
Um,
I can start. I can help you.
Coordinates.
Relation is a set of
Coordinates.
ordered pairs, right?
Oh, order pairs. Yes.
Yeah, and instead of if we are just ordering pairs, why ordered pairs, Shahina? Because 1, 5 and 5, 1, they represent two different things, right?
Mm-hmm.
Because if you are saying that, okay, the first number in my actual set, right, represents the names of my family, like Shahina, Sardar, and Iman, and others. The second number represents their age, right? You can just write age, right? And that's why order is important. The first number represents something, the second number represents something. And also coordinate plane, right? 1, 5 and 5, 1. They are two different points, right?
Yeah.
And that's why we are saying that ordered pairs, because order matters. Okay.
Okay.
Okay, Shine. After this relation, can you tell me what is the definition of a function? How do you define a function?
A function is an
A
ordered
spatial
pair.
relation. Let me just say
Oh, a
a function
special
is a spatial
relation
relation. Okay.
that never repeats.
No. Just
Special.
imagine if you close your eyes, Shahina, when we talk about function or relation, we talk about correspondence, right? In set one, we have something, maybe let's say the names of the people in your family, just to
Mhm.
understand this. The second set, actually, it contains their age, right? And now we are
Yes.
pairing this, right? Shahina, for example, 16 years old. Sardar, 12 years old. Imana, 6 years old, right? Right. So this actually now I am pairing in how every element of the domain, right, is paired with exactly one element of the range.
Yeah.
Remember? So a function is a
Oh,
special
right.
relation where every, we can say member or element, the same thing. Every member of the domain is paired with exactly one member of the range. That's a function.
Okay.
Because function means a correspondence, right? Relation, but it's a spatial relation. Every input value should produce a single output value. Okay. Can you say one more time? What is a function?
It's a special relation that the member of the domain,
Every member
re,
of its domain, yes,
every member of its domain really
is paired
is paired with exactly one member of the range.
member of its range. That's it. You see, you just pick, put into your function, produces one value, right? Another input, right?
Yeah.
Produces another value. Then we say it's a function. Okay. So now what is the inverse of a relation? Okay. What is it? It is a relation that reverses, right?
Yes.
The inverse of a relation is something that reverses our relation. What does it mean, Shahina? It means that I can just give you one example to understand why do we need to study or learn about the inverse function. Later, actually, in pre-calculus, you will study this a lot because some functions, when you integrate, you will need to express them. Anyway, like for example, let me just give you one example. This f of x. Let's say here we have cube root of. Let me just write here 5x plus 2. Okay. So now suppose that's actually, if I write 5, it will be the same thing. It doesn't matter, but I want to change this. Let me just write here. What is it? Uh, Actually, I can just write here 6x plus 3. Okay, let me just write 6x plus 3. Okay. Now, if I ask you, Shahina, this is our function machine. This x is the input value, right? So if I ask you, can you evaluate the value of the function at 4, right? How do you evaluate this? We just plug it into our function, right? X is 4. It
Yes.
is 6 times 4 and plus
Plus
3,
three.
right? And 6 times 4 is 24.
24,
24 plus 3 is 27.
27.
And what is cube root of 27? That is 3, right?
Yeah.
Okay. But sometimes, Shahina, if I give you the distance formula, right? If I give you the time, you can evaluate the distance. In 5 seconds, you travel this much distance. In 10 seconds, you cover that much distance, right? But
Yes.
sometimes if I give you the distance, okay, and if I ask you the time or the speed, okay, at the time I don't know the what is the distance function, but I know the speed function. So from speed, how can I find the distance function? But here, the problem here is, how about if you know that thing? Suppose that you know the output value, okay? Output value is 3. So that is y is equal to 3, right? If y is equal to 3, so what input value gives us 3? I may ask this question, right? So at that time, how do you do that? Okay, here, if this function is y, so y is equal to cube root of 6x plus 3, right? So you know the input output value, that is 3. So just actually plug it here. We have 3. That's equal to cube root of 6x plus 3, right? And now if you solve this equation, you can just cube both sides and solve this. You will get what? You will get x is equal to 4, right?
Okay.
Okay. So that
Okay.
means that if I give you the input value, we have already studied how to evaluate the value of the function. But now the problem is, how about if you're given output value? Can you find its input value? And to do this one, every time instead of solving this, okay, I can express or I can find the inverse of the function so that I can just plug this 3, okay, and it gives us the corresponding input value. Okay, because if input value, if you're given input value, we know how to evaluate output value. But now we're just reversing this operation. If you're given output value, how would we do? How can we calculate or find the input value? Okay, so what is the inverse of a relation? It is the relation, or it is operation that reverses the relation, or just simply that reverses the impact of the function. Okay, and notations, the inverse of a relation R is written as what? R, here we just write an index -1, right? We don't read it as R to the power -1, we just read it as the inverse of R. Okay, and give the inverse of relation R below. So here we have 0, -7, -1, 2, -4, 2, and 6, 3, right? So inverse
Mhm.
means that now we are interchanging the roles of x and y. So how do we find this? We're just
Negative
interchanging this.
0,
-7, 0,
2, -1,
2, -1,
-2, -4,
-4,
3, and 6.
and the 3 and 6, right? Just reversing this. And how about one-to-one functions? Have you ever seen this word before, one-to-one function?
Yes.
What is it?
I think I don't remember the exact definition though.
Can you give me one
That's-
example that is a one-to-one function, another example that is not a one-to-one function?
was it? I'm trying to, I forgot. I've
Like,
heard it,
like for
but
example, I can give you, like, for example, y is equal to 3x plus 1, right? And if
yeah,
you draw its graph is something like this, right? Its graph is something like this. Let me just, when it's 0, it is 1, so it is something like this, right? Okay.
yes.
So what does one-to-one mean, Shakhina? One-to-one means that now every output value, right, is paired with exactly one input value. So that means that one input value, two input value, it doesn't give us the same output value. If you pick two different input values, and also it gives us two different output values, right?
Yeah.
So I'm saying that to be one-to-one, okay, from the domain of this function, if you pick two different values, let's say x1, and another one is x2, right? I'm just taking this from this domain, okay? And if you evaluate the value of the function at these points, f of x1 and f of x2, if they are different for any two different values, then it's called a one-to-one function. And what does it mean? It means that every output value is paired with exactly one input value. So that means that if you draw any horizontal line, it intersects the function maximum at one point. Okay. And how about
Oh,
not
right.
one-to-one function? Not one-to-one function, y is equal to x squared, right? And see here, if you evaluate this, f of 2 is equal to 4. And how about f of negative 2 is also equal to 4, right? And now if you draw its
Yes.
graph, what is it? Its graph will be parabola. Is something like this, right? So one is
Oh,
actually it is negative 2 or 2. We have the same values. What does it mean? It means that two different actually output values, right? Producing the same value because f, our input value is negative 2. That's equal to, also is 2. That's equal to 4, right? So that's not a one-to-one function. Why do we need this, Shahina? Because only one-to-one functions, they have inverse. If it is not a one-to-one function, they don't have inverse. Okay,
okay.
because you are interchanging the roles of x and y. When you also interchange this, the inverse should be a function. So now we just define this. What is a one-to-one function? It is, let's say it is a function. Let's just write the definition where different inputs or simply x, right? Input values produce different output values. Output values. Okay. If you pick any two different input values, all the time, if they produce two different output values, then it's called one-to-one function. Otherwise, like x squared, y is equal to x squared is not a one-to-one function because when it is negative 2, x equals 2 is producing the same value, right?
Yes.
So it fails the horizontal line test. If you draw any horizontal line, if there are two intersection points, it's not a one-to-one function. But here it's a one-to-one function. If you draw another function, for example, let's say its graph is something like this, it's also one-to-one function. If you draw any horizontal line, so we have only one intersection point. Okay, so now horizontal line test. Can you read this part, this paragraph?
Recall, the vertical line test is used to determine whether a relation is a function given a graph. The horizontal line test is used to determine the um whether the
Whether
line
the inverse, right?
or the inverse of a
In
relation is a function.
yeah. So we
Both the
use
relation
the
I was,
huh?
no, sorry, I was continuing to read it.
Yes. Okay. So actually, in vertical line, right? Why did we use vertical line? Because in the definition, we said that every input value should produce a unique output value, right? So which means that when you draw any vertical line, if there's only one intersection point maximum, then it is a graph of the function. And how about the
Okay.
horizontal line test? We use horizontal line test to test if the function has inverse or not. If it is, actually, what is it? If it is a one-to-one function, then it has inverse. Otherwise, it doesn't have inverse. Okay? Yes, China.
Okay.
We're going to say something.
Um, did we stop at the third one?
Yeah, continue. There's
Oh,
also the third one.
both the relation and its inverse must be a function in order to be a one-to-one function.
Both the relation and its inverse must be a function in order to be a one-to-one function. Also, converse is true. If the function is a one-to-one, then it has inverse. Or if the function has inverse, then it must be a one-to-one function. Okay?
Okay. Mhm.
Okay. Read it now. Directions.
Determine whether the relations are one-to-one functions.
Okay. And to be is one-to-one. So we are going to use the horizontal line test, right?
Yes.
Okay, in question one, is it a one-to-one function?
Yes.
Yes, because if you draw any horizontal line, right, it actually intersects or crosses the graph of the function at only one point. Okay. How about two?
Yes.
Yes.
Yes. Because if you
No.
use the vertical line test,
No. 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 We are saying that whether relations are one-to-one functions. To do this one, we need to use horizontal line test, right?
oh, then no.
Yeah, for one-to-one. To be it's a function or not, we use vertical line test. It's a one-to-one function
Oh,
or not, so we use horizontal line test.
okay.
So if you draw a horizontal line test, we have a lot of intersection points, right? More than one. That's why, is it a one-to-one function? No, it's not
Mhm.
a one-to-one function.
Number three is yes.
Yes, because if you do any horizontal line, it crosses the graph at maximum at one point, right? That's
Yeah.
why it is yes, it is a one-to-one function. Today my daughter turned 14, Sarvanas, huh? Sarvanas?
Oh,
So I'm
happy
talking to
birthday to her.
Shakhina. Yeah. I don't know. This young generation, very shy, they don't talk. And last week we visited my brother, their cousins. We went to Dallas. And they play actually, but they don't know what to talk about. They only talk
Yeah.
about games. Today was her birthday, and did you actually? What's the news that Houston was hit by the hurricane?
Oh, really?
There was very strong wind on started on Sunday, and a lot of trees fell down. And
Oh,
now still there is electricity outage in thousands of people. They don't have electricity for like 4 or 5 days already. Now, if you go
wow.
out, you'll see a lot of debris, and a lot of traffic lights still not working. It's a huge city, but a lot of places now. If you travel, it is very dark, no electricity.
Yeah.
It
Wow,
happened on
that's
Sunday, but it's already 5 days. But still, they're trying to restore. But
it takes time.
yeah, so I think we should think to move to maybe Chicago or somewhere. Because the third time it is hit this year. In March also it was
Oh,
very
really?
strong, and even downtown a lot of buildings windows were broken, and there was electricity outage for 3 4 days. But now
Wow.
thousands of people still they don't have electricity.
Wow, that's
Yeah, this is the second time. Now I
yeah.
can imagine if actually a bit stronger storm hits Houston, it will be, affected a lot. It's okay. Actually,
Yeah.
at the time we were in Dallas, so we just came back after we had electricity here. Yesterday we came back. Okay, Shahina, let's continue. Uh, I'm just talking, Shahina, but if you press a few questions yourself on the paper,
Hmm.
you have some idea. Because if you understand all definitions, then you can actually, draw a big picture of math in your mind. So you can make
Yeah.
connections. Okay, this is a function, it's a linear function, quadratic function. Okay, domain, input values, and the range, output values, right? And one is increasing, going up, decreasing, going down. And after that's what is it? Local maximum, local minimum. And these things are not very complicated things. And especially these days, you have technology. If you're not sure, you can just draw, and just you need to have some idea, what do we mean by local maximum, what do we mean by global maximum. Okay, and also this
Yeah.
one-to-one, a bit later when you study actually about differentiation and integral, at the time you will need this idea, inverse functions. Okay, now we are just building our foundation. Okay, because when you
Okay.
inverse a function, also it must be a function, and that's why we are saying that for a function to have inverse, it must be a one-to-one. What do we mean by one-to-one? If you just input two different values and evaluate this function should give us two different output values. That
Okay.
means it's one-to-one. If you imagine, and here we have domain, I can just label this by x, and this one is, let's say this y, right? And every value here actually is mapped onto different value. It's like this into this into this into this. Okay, that means one-to-one. All right, how about four? Is it a one-to-one function?
Yes.
Yes. Why? Because it passes the horizontal line test, right? And that's why. Okay, how about five?
No?
No, because
Um,
it is
yeah.
itself horizontal line, right? It has infinitely many points intersecting. How about six?
Yes.
Is also, yes, is also one-to-one function. Okay, let's continue. So inverse functions. Now let's talk about its notation. And I'm sure that also you know this. Read it. What is the notation?
The inverse of a function f of x is written as
Written as f. Here we have -1. We read this f inverse of x,
oh, right.
right?
It's,
So not all functions have inverse functions. So what functions have inverse?
um, 1 to 1.
Yeah. For a function to have inverse, it must be 1 to 1. And what is 1 to 1? If you evaluate its value at two different values of x, also output values must be different. An example, Shahina, can you give me one example for 1 to 1? So you can give any linear function. Y is equal to x plus 5, or 2x plus 1, or 3x minus 7. All linear functions, a straight line, right? It's 1 to 1.
Mhm.
Of course, it should not be a horizontal line. And how about for example that is not a 1 to 1 function? Just keep in mind that y is equal to x squared. Why it is not 1 to 1? If you evaluate this at, for example, 2 and -2, the result is the same, right? It is 4
Yeah.
and 4. And that's why it's not a 1 to 1. Also, it fails the horizontal line test. Okay, shall I continue? Read the third one to find the inverse.
To find the inverse of a function, replace f of x with y. Interchange x and y, solve for y, and rewrite y as f of inverse of x.
Okay, we have three steps, right? Number one, for example, this function, how do you find the inverse of this function? In the first step, we need to rewrite this f of x as y, because in functions, sometimes we use y and sometimes f of x, right? They mean the same
Yeah.
thing. So first, we just write y and 4x minus 8. What is next?
And then we change the 4x to 4y.
Relabel this, right? We label y as x and
Oh,
x by y. Actually, this y is the inverse of the function. And after
mhm.
that, we need to solve it for y. If you solve it for y, we will get this thing, right? That's equal to move a to the left-hand side and divide by 4. So that is 1 over 4x plus 8 divided by 4. It is 2, right? And
Oh,
after that,
yeah.
rewrite y as the inverse, because not to get confused, so this thing is the inverse of the given function. What is it? 1 over 4x plus 2.
Okay.
And what does it mean, Shahana, again? Once again, for example, in the first step, right? If you evaluate when x equals, let's say it is 5. So what is y? Y is equal to 4 times 5 minus 8, which is equal to 4, right?
Yes.
Okay. So now, Shahina, now this one is output value. If you evaluate the inverse function at this value, it gives us 5,
Oh,
right? Like, for
yeah.
example, let's just see this, because if you just write only one example, you'll get some intuition. So what is my inverse function? Inverse function is this, right? X. What is X? It is 4, right? That's our output value. Now it's input
Mhm.
value for the inverse. Now evaluate this, 1 over 4 times 4 plus 2, right? So which is equal to, is it 1 over 4?
Would it be
No, no, no.
plus?
Why did I write here 4? It is 4 times 5 is 20. 20 minus 8 is 12, right?
Yeah.
It is 12. Because 4 times 5 is 20. 20 minus 8 is 12. So here, so I need to evaluate this value at 12. So if it is 12, here we have 12 plus, right? And now
That would be
12,
5.
1/4 of 12 is 3. 3 plus 2 is 5.
5. Okay.
Input value becomes output value becomes input value. Okay, this let's just do mathematical part, and later also we'll see its application. Why do we need this? So I'll give you, for just, can you tell me, I'm going to write here, okay? Whatever you tell me, then next question will be in the paper. So what should we do in question A, the first step?
So you would do y equals 1 over 2
Okay,
x
so
cubed minus 1.
replace f of x by y, right? So
Y.
y is equal to 1 over 2 and x cubed minus 1. Next.
And then interchange x and y. So it'd be x equals 1 over 2 y cubed negative and minus 1.
So here we have x. So here we have 1 over 2 and y cubed minus 1. Next step.
And then um
Solve it for y,
solve
right?
for y.
Yes. Can you solve it mentally? What is y here?
Y equals um 1 over,
No, first you move negative 1 to the left-hand side, x plus 1, right?
yeah,
And
yes,
multiply by 2, 2 times x plus 1, right? And take cube root, right?
yeah.
So which is, so dot, 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 the inverse of the given function then would be cube root of 2 times x plus 1,
Oh, okay.
right?
Yeah.
Okay, good. Now, Shahana, you try to do question 9, okay? I'll give you 9 seconds and tell me your final answer. Let's see if we get the same thing or not. If we got different things, we will discuss. If not, we will move to the next question. Yes, Shahina.
Um, I'm almost done. So that's solve for y. Wait, x minus 6.
Hmm?
Um, I am not sure I did it.
Yeah, just can you tell me, did you get anything or
I'm kind of confused. I'm like, I
confused?
didn't get the right answer.
So first, did you write y here? Y
Yeah.
is equal to x minus 4 squared plus 6, right? And now I
Oh,
can also actually we can just solve it for x, then you can change it, okay? It doesn't matter, the same thing. Now if you solve it for x or immediate, I can change it. Okay, here we have, let me just write here x, and here we have y minus 4 squared plus 6, right?
yeah.
What is next, Shahina?
You would move subtract 6 from both sides.
Yes, then here we have y minus 4 squared will be x minus 6,
X
right?
minus 6. Yes.
And next,
And then you would square root both sides.
no, yes, square root. If you square root, we'll get y minus 4 will be square root of x minus 6, right?
Yeah.
That's it. And move this to the right-hand side. So we have dot, dot, dot. Then f inverse of this function would be square root of x minus 6, right? And
Plus
plus
4.
4.
Oh, you didn't need to solve it? Or okay.
No, I just solved for y,
Okay.
right? And after that, again, we
Yeah.
just replace by y f inverse.
Okay. Okay.
When we studied trigonometry with you, Shahana, do you remember you use this inverse function a lot? Sine inverse, cosine
Yeah.
inverse. So that means you are just interchanging uh, rules of this. Okay, let's continue. Now do question 10, Shakhina.
Okay.
1 minute. Your birthday was on the 21st of March, Shakhina?
20th of March.
Oh, just
Yeah,
1 day before Nowruz.
yeah.
Okay.
Y minus 8. Then, okay. I got 5
Mm-hmm.
over x plus 8.
Very good. Very good. That's correct. So, inverse of this function is, what did it say? 5,
5x plus 8.
5
5
over
over x.
x, right?
Yeah.
Plus 8. Good. Now do 11. I try to do a bit faster. If you do 1 or 2 questions correctly, that means that's you got the idea. The rest of it is just algebraic manipulation.
Okay. If I square both sides, would the negative um affect like y and 2?
Yes,
So it's negative
because
y
Shahana negative
minus
a
2.
squared is equal to a squared, right?
Yeah, x plus 1 squared plus 2 equals negative y. And then y equals negative x plus 1 squared minus 2. Is it negative x plus 1 squared minus 2?
Again,
Negative and then in parentheses x plus 1 squared equals, no, negative and then x plus 1 squared minus 2.
x minus 1? Why 1? You mean 7?
7.
Because here, first step, it is y, right? Is equal to
Oh my god, it
minus,
is 7.
yeah, it must be 7.
I read that as 1, I'm so sorry. Yeah, 7.
Okay. Now, if you interchange this, here we have x is equal to minus y plus 2 minus 7, right?
Yes.
So you move this negative 7 to the left, and after that, square on both sides, right? And we'll get this
Yeah.
thing, right? X plus 7 squared is equal to y plus 2. Is that right?
Negative y
Why
minus
negative
2,
y?
right? Or would that
negative 1.
not? Okay.
Because we have square, right, Shine? It is minus, let's say,
Yeah.
a squared. What is it? That's equal to a, right?
Yes.
Because negative 1 squared is
Okay.
1, square root of a squared is a. So from here, the final answer would be the inverse of the given function would be
X plus 7 squared
x
plus
plus
2.
7 squared
Oh,
minus
minus
2,
2.
right?
Yeah. Okay.
Okay. And how about 12?
12.
Because in the quotient, it says that, you see, determine if f of x has an inverse. If yes, find the inverse. And state any restrictions in the domain.
Okay.
Okay. So because here, 1, it's one-to-one function, and not 1, 7. Question 7, one-to-one function. 8, one-to-one function. And 9, is it a one-to-one function?
Yes.
No,
No, it's not.
it's not.
Because it has like an X squared.
Yes. So that's why it says that determine if f of x has inverse. If yes, find inverse. If not, state any restrictions in the domain. Okay. That
Okay.
means that Shahina, like as I told you, if you just consider this example again, y is equal to x squared. Right? And what is graph? Graph is parabola. So this is y, and this one is x. Its graph will be something like this, right?
Yes.
Is it one-to-one function?
No.
No, right? But how about if I just close the left-hand side and if I just add this restriction? Suppose that x is greater than or equal to 0, right? At the time,
Y-
if you draw its graph, it will be only this part, right?
Yes.
Now, is it one-to-one?
Yes.
Yes. So this kind of, if I bring this restriction, it becomes a one-to-one. Now I can find its inverse. Then what is it? It is square root of y would be equal to x. If you interchange this, the inverse of this function would be square root of x.
Okay.
Okay. And what is our restriction? It is this. As you see here, square root of x, it cannot be negative number here. So x must be greater than or equal to 0.
Okay.
And that's why here, for this function, right, uh, question 11, we found this. But what do you think about, actually, this is one-to-one? Okay. 11 is one-to-one. Oh, actually, 9, right? It's not one-to-one function,
Yeah.
right? So to be one-to-one function, so we should just actually, what is it? Divide the parabola into two halves. Do you remember
Yes.
how we find the, uh, if you look at this, China, if you remember this, okay? If not, I'll just remind this. It's a parabola, right?
Yeah.
Can you tell me what are the coordinates of its vertex?
Um,
Hmm?
mm, I'm not sure.
Coordinates of the vertex is, x minus 4. One is equal to 0. One is equal to 4, right? So when it is 4, the value of the function is 6.
Okay. 4, 6.
Maybe you didn't study or you're going to study later. In quadratic functions, and if you just write in the vertex form, here we have a times x minus h squared plus k, right? And suppose in our case a is positive. So that means that it looks up. And this one is turning point. We call this vertex, right? So what are the coordinates of the vertex? It is h, you see this h and k. So that means, Shaina, if I just draw here a line, vertical line, it will be the line of symmetry.
Yes.
Right? If you just cut this into two parts, then each part becomes a one-to-one function. Okay, maybe later I'll show you in detail, but our main topic here is finding the inverse. So what is my restriction would be? Since it's not a one-to-one, if I just write here, okay, x is greater than or equal to 4, the given function becomes a one-to-one function.
Okay.
Okay,
Okay.
all right. And how about
Okay.
question 12?
Um,
Is it a one-to-one function?
yes.
No.
No.
You know this absolute value?
Yeah.
Absolute value is something like V shape, right?
Yes.
Um,
So it's
okay, Shahina, let me just show you. Later, you can also practice yourself.
mhm.
You can also use symbol lab or just like this. So like absolute value function is like, for example, absolute value of x.
Oh, I see.
Because absolute value means that if x is always positive, right? When x
Yes.
is greater than 0, it's fine. Y is equal to x. If x is less than 0, then y becomes minus x. And now, if I just write this function, right, our function is negative 3 over 2 and plus 1, right? So I just here write here negative 3 over 2 means that if we have negative 1.5 and multiplied by this, and here we have x plus 1. It will be a bit similar thing, but because of this negative is reflected about the what is it, x-axis. So this is the graph of this function. Okay, what you have to know here is, Shahina, you see this x plus 1 when x is greater than negative 1, right? You see, when x is greater than 1, it's just this part of the function, which is 1 to 1, right?
Yeah.
So just I need to take this part. So that's why I'm adding this condition. So for this to be 1 to 1, so if I just add that here, x is greater than or equal to negative 1, the function is 1 to 1. If it is
Okay.
1 to 1, now we can find it is inverse, right?
Yes.
If you say yes, Shahina, after adding this condition, x is greater or equal to 1, can you tell me what is the function here? Y is equal to what? What will we have on the right-hand side?
Um, wait. I don't
Negative
think
3
I
over 2,
understood the
right?
question.
Negative 3 over 2, right?
Negative.
And x plus 1. You know why?
Oh, why?
Because absolute value x plus 1, right?
Yes.
If x is greater than or equal to negative 1, is it greater than or equal to 0?
No.
Okay. So if x is greater than or equal to negative 1, right? So this x plus
Yeah.
1, x plus 1, will it be greater than or equal to 0?
Yes.
Because x plus 1 will be non-negative, right? When x equals
Yeah.
negative 1 or 0 or 1 or 2 or 3, right? It's always, so
Yeah.
that means that by using the definition of the absolute value, at the time, this will be, this x plus 1 will be equal to x plus 1. If
Oh,
x is,
are you
yes,
writing or
yes,
because I only see the graph.
really?
Yeah.
Oh, I shared only the graph, and that's why you were,
Yeah.
oh, I'm sorry, Shahina, I thought, oh, I shared only the graph. Okay,
Yeah.
all right. And I'm
Okay.
talking about this question 12. Okay.
Yes.
I'm saying that. So look at the graph, right? If x is greater than or equal to -1, so this absolute value of x plus 1 will be just x plus 1, right?
Yes.
Because it is non-negative. And that's it. Now, what is it? It's just a linear function, right?
Oh,
And it's
right.
a
Yeah.
one-to-one function.
Mhm.
And that's it. You know how
So,
to find its inverse. What do we do
yes.
next? Interchange, right?
You, yeah.
So that is x, and here we have 3
Seven
over 2, x
times.
plus 1.
Would it be y plus 1?
That's right. Y plus 1. Or, so here we have y plus 1 will be equal to minus 2 over 3x, right?
Yeah.
Okay, now here dots, dots, dots. Then f inverse of the given function would be -2/3x minus 1.
Minus 1. Okay.
So I had let's do question 13 and 14 and we'll finish the class, okay?
Okay.
Before you start, can you tell me 13, is it a one-to-one function or not?
Um, no.
Why not?
Is it?
It is a one-to-one function, right?
Okay.
Why?
Because I'm not sure.
Because if you just substitute any two different values for x and evaluate this, it always gives us two different values because it's cubed here.
Yeah. Okay.
Because if you, for example, let's say x is, let's say 5 or x is 9, right? Whatever it is. Because if you're given two different numbers and subtract 9 from that number and take the cubic root, right? And divide it
Yeah.
by 4. And if you calculate a different number, the result will be different.
Oh, okay.
Because if you can say like this, maybe actually, because if I draw the graph, it fails the horizontal line test. But now imagining the graph is not easy. Okay.
Oh,
So
yeah.
this algebraic way is you can just show this here. All right. If you just pick two different numbers, f of x1, and evaluate this, and if x2, two different numbers, always it will be different if x1 is not equal to x2.
Oh, okay.
Usually, Shahina, when actually it is not one-to-one, if the degree is square or square, okay? Or like the power is 4, or trigonometric functions, but it's like cubic root or fifth root, they're always one-to-one function. Okay, now suppose that actually we know that it's not, what is it? It is a one-to-one function, so it has inverse. Find its inverse, Shahina.
Okay. Um, y equals 1, 6, x, mm, 4. Okay, I got y equals 4 in parentheses 4x and then cube plus 9.
Okay, so 4x is in parentheses, right?
Yes.
So if you expand this, what do we get?
Um, 4 cubed and oh wait,
Yeah.
that's
So what is 4 cubed?
times 16, 16
60?
times 4.
64,
Um,
right?
yeah,
Because 4 times 4, 16. 4 times 16 is 64. So we have 64
x
x cubed
cubed plus 9.
and plus 9. Good. So I know let's do question 14 and finish the class. Okay, the last question.
Okay.
As you see
Uh,
here, it's already given the condition here, Shahina. F of x 3x squared minus 1 is quadratic function. It's not one-to-one. But if x is greater than or equal to 0, then it becomes a one-to-one function.
okay. So then
All right.
it's y equals 3x squared minus 1. Um, is it y equals square root of x plus 1 over 3?
Yeah, that is square root of x plus 1 over 3. Right.
Yes.
Shahina, that's it. I will send you this paper, okay?
Mhm.
And at least you're on a holiday, maybe you're busy. If you can do maybe 6 questions. If not, just we can have a
Okay.
look what kind of question we have. And if you just come to the club with idea, you'll go much faster. Okay?
Okay. Yeah, sounds good.
Shahina, enjoy your holiday. Eat a lot of shashlik and palau.
Yeah.
All right. See you next week. Okay?
Yes. Bye
Yeah,
bye.
say salam to your family. Yeah. Thank
I
you.
will.
Bye bye.